Hello, welcome to Let's Learn, Play, Teach episode 3. I guess we're making a game as well. So this is episode 3 of a continuing series where we are looking to create a game, but first we need to learn how to use the engine. So not just the engine actually, we're going to be doing the 3D modeling, we're going to be doing the audio production, scripting, AI, pretty much everything that you need. I'm just one man who's going to be doing this sort of stuff. So it's not my first game. It's sort of it's actually my third. But this is something I absolutely love doing. I used to use Unreal Engine. We're back into Unity. So what I'm going to be doing today is jumping back into the course that we've been doing. I can't quite remember where we are, except for what we did was I remember we put a scene and we put an object into that scene, and we're just sort of learning how to use the controls, manipulate the game space, the developer space, and just going into the next bit, which is actually coding. I seem to remember. So here we have, actually I've turned off HDR this time, so it shouldn't be too bright for the first couple of minutes, because twice I've left that on. And the audio mixing as well. I've got some royalty-free music on, and also I always find the mixing is a bit more difficult to figure out, so as we go I'm learning to stream as well. This is the third time I've ever done anything like this in my life. It's quite a new experience. It's quite exciting. So I guess we'll just sort of get back into the Unity learn, and as we're going along, I'll just talk about sort of where I've come from. I've sort of made 2 home projects. One was for Android and one was for PC. Both working with an artist and an audio producer, and a lot of the time I was using ClickTeam Fusion actually, which is a 2D game engine using object-orientated programming. Not quite the same as this, I guess, but yeah. So we're familiar with Unity at this point, I hope. Using just the basic controls. We've done a couple of these courses now. So next up, we're going to be doing the Junior Programmer course. Just going to go for it this time. Learning to code. My experience with coding, I guess I can do a little bit if I want to, but I'm not going to beat around the bush and say I can code. Just sort of understand it. I know what it is. And whenever I'm required to do any sort of PowerShell or anything to do with coding, specifically with C or anything like that, I just kind of learn. Kind of get an objective, put together what I need, and go for it. Quite like this music. I like a bit of sort of chilled out vibes. Are we not signed in? Okay, let me just sort that out. So I'll just sign in over here. Try and remember all the bits that I need. I'm hoping to do this more as well. I found I've been so busy in the last 2 weeks, I haven't managed to do episode 3, so I do apologise. And the other thing I've learnt as well is to leave open the Restream chat, which I think will pull from Twitch, Twitter and YouTube. YouTube being my favourite one. I watch a lot of YouTube videos. So I need to actually just reduce the OBS settings as well. So I think the stream should be about, it's on 6, which is too high. I just need it on 4, so we'll just reduce that down to 4, and it should still be clear on your end. So let's take a look here. I just want to make sure that as well this thing's actually working, because as I say, brand new, not used to it. So let's check your channel. This thing's actually working. It's working. What I'm going to do is make sure I'm logged in. I think I should be now. There we are. So we're going to resume this pathway. Right, so we created this scene. We dropped a couple of boxes in it, ready for the camera to stick to the car and I guess either use the directional keys or the WASD keys to move the car around. So let's have a look. So the overview. In this lesson, you will create your very first game project in Unity Hub. You will choose and position a vehicle for the player to drive and an obstacle for them to hit or avoid. You will also set up a camera for the player to see through, giving them a perfect view of the scene. Throughout this process, you will learn to navigate the Unity editor and grow comfortable moving around in 3D space. Lastly, you will customize your own window layout for the Unity editor. I forgot to mention, which is quite important as well, is we're doing this for a very good friend of mine, Adam Llewellyn, who's been making a YouTube series called The Vale. So if I just show you, we'll watch an episode of this towards the end of the stream as well. Again, I just think these are absolutely fantastic episodes. Really good writing, good. The acting's really good, the scripting's good, and he's making it with a team. It's all from his head. He's the main driving force for all of this, and he's doing really well. So support him, like him, subscribe. I guess subscribe to Super Hyper Turbo Games as well, which is the business that we're going to be making this under, the developer that we're going to be making this under. I don't just make games. We've also got UNI Radio, which is good to listen to. I would play it, but I can guarantee that you get sort of copyright ban or cause or whatever. So I'll just be putting on some YouTube friendly, non-royalty music. So we got UNI Radio, and I've got this other sort of thing going on, which is websites and computer repairs and an app in development as well for supermarkets. So I kind of just do a little bit of everything. And I've been on video games since I was about 3 years old. I'm a lot older than that now, but yeah, it means I've been doing this for a long time. Love it. Okay, cool. So it's got here. You will have a vehicle at the end of this. So a bit of a digression then. I just wanted to catch you up on the main bits. Should always remember to do that. You will have a vehicle and obstacle positioned on the road, and the camera set up perfectly behind the vehicle. You will also have a new custom Unity layout, perfectly optimized for editing. So I'm just sort of, because I've just sort of gone for it today. So yeah, as what we do, we all learn together. The lesson that they taught us before was to watch, then do. I think it was. So we're going to go through the tutorials together. I think we kind of went through add an obstacle and reposition it. So we've done the lesson 1.1 at this point. Now we're going to be looking to program it. So let's just take a look at what we've got. Just take a second. So the video game that we're going to be working towards is two games in one. You could say it's sort of like an overworld map where you can walk around and explore in a 2D art style. So he's going to be using the art style that Adam uses inside the Vale, and then when you select the level that you want to go to, it will be a sort of a Street of Rage sort of idea, something where you're fighting from left to right, picking up weapons, items, power-ups. There's going to be a mini-boss and then a main boss at the end of the level, and it's going to be about nine levels at the moment, with a couple of little sort of Easter egg houses and bits that you can go into on the overworld. The one nice thing I always remember is sort of like a stick of truth sort of design to it. We'll skip the version. I'm also going to reduce my hertz down to 60 hertz as well. Stop the G-Sync stuff kicking in, so it's a bit better. create with code. So, a bit of a recap. Plonk the tank down. There was actually different models. So don't forget we're learning together. So I'm going to be trying to remember as we go along. But as we ramp up, tomorrow I'm going to do another stream. We will get more familiar with it together. Can't remember what most of the stuff does. But in the thing, they wanted to put us down this car here. I'd rather a tank. Tank's more entertaining, so we're going to put that down. And we plonked down these as well. Evenly spaced. I think it was about 25 or 75 between them or something like that. So just select the one. Y-axis is 180. Sorry, Z-axis is 75. And this one is 100. So yeah, it's about 25 pixels in between them. Not pixels. I wonder what the units of measurements are actually for this, because I've been working in 2D game spaces, which meant that the coordinates were absolute 0 up to whatever the resolution of the game space was. But that there is more than 100 pixels. So I'll look that up. There's no sort of... I wonder if there's a... It's just a relative position based on the actual engine itself. So I'll call them units, I think, from now on. Okay, here we go. So this is our little map. I'm holding down the right click button here, moving around with the WASD. There is a background, there's a road, there's the tank, the vehicle, and then we've got a couple of objects in between. So here we go, and there's the camera as well. And I imagine the light source is here. I'm not going to move it around too much, but can you... It's just a floodlight, a skylight, so moving it around, it's not a directional light, a point light. It's sort of, as I'm moving it, it's not making any change. If we change to rotation, which is E, let's take a look. Can we move it around? There we go, look at that. Nice. Okay, so just gonna mess around with it really, make it look, flood the area a bit more. Okay, so now we've sort of caught up with where we are. Our layout, we'll leave it as this. No, let's go through these layouts and see what we've got. Now this is my favourite kind of layout, and I used to work in Unreal Engine in this type of layout. So you got your Y, your Z, and your X's over here, and then your game space there. Your asset library here. It doesn't leave much sort of room to maneuver around. So let's just move the layout around a little bit. We can drag these titles up here. That looks like it fits in quite well there. Let's bring that down. Bring that over and bring this down as well. Well, we can't bring that down, that's fine. So let's just find out where we are. Lesson 1.2. So I already described the first lesson. This is lesson 1.2, so I'm going to go over it again. In this lesson, you will make your driving simulator come alive. First, you will write your very first lines of code in C#, changing the vehicle's position and allowing it to move forward. Next, you will add physics components to your objects, allowing them to collide with one another. Lastly, you will learn how to duplicate objects in the hierarchy and position them along the road. You will have a moving vehicle. In the project outcome, you will have a moving vehicle with its own C# script and a road full of objects, all of which may collide with each other using physics components. Just gonna have a quick drink. Bit of water. Nice. Okay, here we go. This was quite loud before, so hopefully you can hear it okay.
We've positioned the vehicle at the start of the road with an obstacle directly in its path. Well, last I checked, this wasn't a parking simulator, it's a driving simulator. So we're going to give this vehicle a little gas. And by the end of this lesson, the vehicle will drive down the road, crashing through the obstacles in its way. In Unity, all of the game objects in your scene are made up of components. And it's these components that determine how your game objects will look and behave in the scene. So if you want a game object to behave differently, you just need to change its components. Let's take our vehicle, for example. Right now, it doesn't have a lot of components. It just sits there doing nothing. In fact, it doesn't even obey the laws of gravity. If you raise it up in the air, it would just float there like a vehicle-shaped cloud. But if you add a particular component that tells it to obey gravity, it'll fall. What we need, though, is a custom component that will make this vehicle drive down the road. So, we are going to create that component by programming it from scratch in a new C# script. After we write the code that will move a game object forward, we'll apply that script component to our vehicle, and our vehicle will move forward. As you'll quickly find out, programming is very powerful. Just a single line of code will make that vehicle fly down the road. So to make all that happen, I'll see you in Unity.
Cool, okay. So, I'm gonna pause the music, by the way, when it comes to it. There's music in the video, which is a bit conflicting. Sorry. That was nice to know. It reminded me a little bit of when I used to do the 2D stuff. So, because it's on a per pixel basis, the gravity was simulated. So if you can imagine, on every frame you can move an object 1 pixel, which meant that 60 frames per second, you would move it 60 pixels per second essentially, and then using that downward, you would minus the pixels every frame from whatever axis you wanted it to start at, from whatever coordinate you wanted it to start at on a particular axis. You could create anything. You could create bouncing balls. You could create sort of objects that would hit a collision object, and it's very similar. This thing here, we're going to create something that allows it to fall and hit an object. So I'm going to pause the music now and click play on the next item.
Now watch and pay attention before you do this yourself. We have our layout set up nicely here.
I can play the music again. I thought there was music.
In Unity, so everything is nice and organized. We have our scene set up. So now we're actually going to create our very first C# script to be able to control this vehicle's movement. In order to do that, we're going to go to our project window and then make sure you right-click on the assets folder. And then you're going to go to the create button and we're going to create a new folder. We're going to name this folder scripts because this will actually be holding all of the scripts that we'll use to manage all of the interactions in our game. Now, it's very important, especially as you start a project, to keep all of your different folders organized so that way it's easier to find all of the different things that you need, whether it's your assets that you're using in your scene, like in our course library, or different scenes that we need to manage, or in this case, our scripts, so that way we know where all of our programming is being done. Now, what we're going to do, we're going to make sure it gets added to the scripts folder. So we right-click over our scripts folder, and we create a C# script. Now we're going to name this script player controller, capital P, player, capital C, no spaces, controller. Now, when we press enter, Unity will automatically create this script for us, and we can actually preview it on the side. So you might be wondering to yourself, why did we capitalize the P and the C, and why are there no spaces? Well, this is actually something called a naming convention, and this is just a standard thing that developers do and people do when they're creating their projects, as a way to make it easier for other people to jump into somebody else's project. So if somebody were to play around in your Unity project, they could understand the scripts and all the things that they're supposed to do and what they are. So capital letters for each word in a script makes it really easy for people to know that what you have is a script right there. Another reason to name scripts up front is because it can actually create a pretty large problem in Unity. So what I'm going to do is on my scripts folder, if I right click on it and I click create C# script, and I don't know what to name this script for now, so I'm just going to call it test. And so here you can see that the test script is created, and you can see that it's previewed over in the inspector. Now, say later down the line, I want this to do something. I don't know, maybe for some reason I want to make the obstacle fly or something like that. And then I press enter. So we've renamed this script to be obstacle fly, but in our inspector, you can see the preview of our script. It's still called test, even though we just changed it. So this could actually potentially break things in your project and create conflicts between the name of what you have in Unity and the name of your script. And so it's just better to name everything up front, name it exactly what you want it to do, and make sure that you use the standard naming convention so that way it's easier if other people have to jump into your projects. So I'm going to just right click on obstacle fly, and I'm going to delete this from my scripts folder because we don't need it. So we have our player controller script now, and we're going to left click and drag it onto our vehicle. And now, if I click on my vehicle, you should see on the right side in the inspector that there's a player controller script that's been added to our vehicle. Now, scripts are the way that we're going to actually create all of these different interactions for any of our obstacles, our vehicles, even our camera in our environment. And so when we want something to do something, we need to use scripts to be able to tell Unity what we want that thing to do. In this case, our player controller script will make it so we can actually move our vehicle and control it. In addition, when we dragged our player controller script onto our vehicle, you can see that it was added here in the inspector. And so it was added to our list of different components. And so our components are basically the different properties that we can see attached to all of the objects in our scene. So, for example, our vehicle has our transform, so it can control the position in the world, how it's rotated and oriented, the scale. We added our player controller script, so we know that we're going to create a behavior for this vehicle. And then there's other things too, like mesh renderers and mesh colliders, both of which we'll get into later. A mesh renderer just helps to actually enable Unity to show you the vehicle with all of these textures applied onto it. And the collider will actually be something we use later so that we can have our vehicle run into our obstacle. Now, for example, if we went onto our obstacle and we accidentally added our player controller, which we can also do by left clicking and dragging onto our inspector if the selected object is highlighted, we can add it that way, but I don't want the player controller on this obstacle, so I can click this gear icon next to it and we can actually remove that component. Or if I wanted to add a component another way, I could also click the add component button, and you can actually see all the different components that you could use if you ever wanted to, or you can just type in the name. So we have that player controller, added it there, but we don't want it on our obstacle at all, so we're just going to click on the gear, remove that specific component, we're good to go. So what you're going to do is you're going to right click on your assets folder, create a new folder, name that folder scripts, so that way we can see where all of our scripts in our game are being managed and organized. On the scripts folder, you're going to right click directly onto it and create a C# script, which you will name player controller, capital P, no space, capital C. And then you're going to add the player controller script either by left clicking and dragging it and dropping it onto our vehicle, or if you select the vehicle by clicking on it, you'll see it pop open in the inspector. You can left click and drag the player controller into the list of components. Or if you have your vehicle selected, you can click on the add component button. You can type in the search bar and type in player, and that'll pop open your player controller script that you can see here, and you can add it that way. Now it's your turn.
Okay, let's seems quite straightforward, so let's crack on with that. I've moved things around, so it looks slightly different, but essentially we can select our tank over here. Let's create our folder, scripts, and create our player controller. Now, what you said is really interesting, and we will go over this a couple of times, is the naming conventions. He's absolutely right. As we go through, over here, I've called it object collision boulder, object collision, and I like to, for myself at least, what I do is give just a quick indicator of what it is on the left hand side. So we have our objects, so you can always see them organized in a tree nicely, and then a little bit of an attribute, whether it's collision or not. I guess we've just decided on that for some reason, and then what it actually is. Now this is its primary purpose is a collisionable object, so I guess that's why we got it there. Vehicle, it's just the standard vehicle, but perhaps this would be something like it's an object, but it's the player object, and it's a tank. So then we have an object, because it's in front. If there was no object, I wouldn't put object there. I'd just put sort of camera, CAM, or player tank. But that's what we've got. In fact, let's find the main camera and let's. Like so. Okay, so we know that's going to be attached to it at some point. Next, we can select our tank, drag it onto that, and then we'll see it in the list down here. Cool. So is that bit done now? Let's put that over the side. We don't need that for a minute. Done. Mark as complete. I won't normally do that, but okay, cool. We're on to the next bit. Let's see where we go.
We've created a scripts folder, and we've created our first C# script, and we've applied it to our vehicle as a component. And now we're actually going to get familiar with our script and the structure of it before we write any of our code inside of it. So make sure that in your assets folder you have it expanded, and then you open up your scripts folder by expanding it. And then if you double click on the player controller script, now you can see that my script has opened up in my IDE, which stands for an Integrated Development Environment. And basically, an IDE enables us to actually interact with our code and write lines of code and text inside of it. So you can actually see there's words that you would be very familiar with, like words like using and public and class. And so very similar to how you would write a note or write an essay in a text document, our IDEs enable us to actually write for our programs. So I'm just going to clean mine up a little bit. There's a whole bunch of information here that's not entirely necessary, so I'm actually going to go on my IDE, close this little Solution Explorer. I don't really need that. I don't need the Team Explorer either. I don't need the properties. Cool, so now I have a full screen. I'm going to make this a little bit larger. It's just a little hard to see. So on the bottom left, I have this little zoom option. So I'll set this to 200. It's pretty good. Now, my IDE is set to Visual Studio. That's actually the default that you would get downloaded on Unity. If not, you can always go to the website to go download Visual Studio from Microsoft. You might also notice that some of the colors are very different. Maybe you have a white background. That's just a setting of mine. I just turned my settings to be a dark background. I use some different colors for words because it helps make it easier for me to see. So you can change those settings on your own, or if you're using a different IDE, then you should be able to customize it in your own ways. But if you download Unity for the first time, you will download Visual Studio. Now, if we take a look at our class, I mentioned it before, but you can see all these words that are very familiar to you. Words like using, words like public and class. And a really helpful thing about an IDE is that in my case, it actually highlights certain words that are very important for a person and a computer to understand. So the different words that are actually highlighted in blue are standard keywords that your computer is made to understand. With our script itself, our player controller, you can see the name that we made before, and in fact, there's this weird colon icon. And so that icon actually means that this player controller inherits from another class called monobehavior. And monobehavior is actually a class that's applied to all the different objects that we create. So actually, if we made a script for our obstacle, it would also use things from monobehavior. And that's very helpful because in monobehavior, a lot of different things that we would need to write ourselves are already made in Unity. So it's really helpful and really easy to get started. For example, we have these two methods here, and you can tell they're methods because they have the word void, and then they have these parentheses, and then they have these curly brackets. So this usually tells you that this is a method statement, and here's actually where we can go write in some code if we wanted to. So start is a method that, as you can see, actually has a comment up here that is called before the first frame update. So when you press play on your game, it would call the start method. Versus the update method, another method from monobehavior. And update is called once per frame. So this is actually constantly checking in your game for different calculations it should make, or different things that it should be checking against if you have a box that collides with something else or something like that. And the difference here, you can see, so these two / marks actually create a comment, and your computer will not read what is on this line of code. So comments are for the purpose of a person to understand what they're reading inside of a method, versus the methods are actually the pieces of information that your computer needs to run certain tasks. So now, in our update method, we're going to write our very own comment. So make sure that you have your text selection inside of the update method. And then if you write / 2 / marks, we can say we'll move the vehicle forward. And so now this is where we're going to write our line of code to move the vehicle forward. But for now, we're just going to make a note for ourselves that this is where we're going to do it. So what you're going to do is you're going to double click on your player controller script, and then your player controller script should open in the integrated development environment, or IDE, that was set by Unity. And then in your player controller script, down in this section of code here, right after public class player controller, you can see all of the different methods that are automatically added by Unity. And specifically in our update method, we'll write a comment using 2 / marks so that we can tell ourselves that this is where we'll write code to move the vehicle forward. Now it's your turn.
Okay, I was expecting a bit more than that, but okay. It's just about comments. These have been around for as long as coding's been around, essentially. Something that gives the human an indicator. So let's just crack on with that. So it wants us to double click the player controller script. Not now. I don't want to. Let's get a dark version like he did. That would be nice. Here we go. Okay, what about now? Here we go. Okay, so because I've selected the dark theme, I'm just going to control and scroll, which does the same thing as what he was doing. I'll just make it a bit bigger so you guys can see. And we're just going to put a comment. I don't want to, but I want to use the community edition. It's just doing something else. Uh-oh. Boys and girls, I've remembered my password. Just have to do my 10-factor authentication. Please hold caller. I did that thing where I deleted the authenticator app. Oh, I need to verify the address. It's all going on the other screen. All going on. So that should, there we go. It was 80085 if you wanted to know. Cool. We'll move the player forward. Okay, so we've done that. Control S to save it. Mark is complete. And now we're on to the next one.
We've opened up our player controller script, and so now we can see all of this code that's inside of this script. And so we'll actually write our own line of code so that we can make the vehicle move forward from our little note we made for ourselves before. Make sure you pay attention before you do this. So what we're going to do is we're going to write our very first line of code here in our update method. So if I select this text block right after the word forward, if I press enter, so this creates a new line. So in programming, a blank space doesn't matter. Our computer just knows that there's nothing there. And what we're going to do is we're going to program using a programming language called C#. So everything that's done in Unity uses C#. If you're going to make a mobile application or if you're going to make a website, there are other languages that you can use to create those different kinds of applications. But for our game, we use C#. And C# is just one way that we're able to communicate directly with our computer using certain words that a computer is able to understand to do something that we want it to do. So in this case, we're going to write a line of code to move our vehicle. Now, what I'm going to do is I want to help visualize moving this vehicle down the road. So if I actually select the vehicle in my project hierarchy, so now you can see it's selected. If I left click on this blue arrow, I want to move the vehicle down the road. You can see down in the game screen. That's exactly what I'm trying to do. In fact, if you look in the inspector on the right side, as I'm moving this blue arrow in our transform component, you can see that the Z is actually updating. And so that gives us a really good hint of what we're trying to accomplish. So if you remember, our transform component was the thing that was updating as we moved that vehicle in the scene. In fact, we can actually use the transform component directly. So if I just type in transform And in this case, lowercase versus capital case T is extremely important. They're two very different things. The transform is actually an entire class, very similar to our player controller class that has even more methods inside of it. A lowercase t means we're getting the transform component of our current object. In this case, it's going to be our vehicle. So now that we're getting our vehicle's transform, what we actually want to do is we want to move that vehicle in that Z direction. So we can use a method using a dot. So a dot will help us get methods out of our different classes and objects. So dot translate. And so you can see here this is a capital T because this is a method just like our update method. And so what is happening here is we're telling our computer we want it to do a specific instruction using this translate method. We want to translate the position, we want to change the position of our vehicle using its transform property. Now, to tell the computer that we're trying to make it do a task, we need to use these parentheses. And a really handy thing that my IDE does, it is actually suggests different things that I can do and can autocomplete certain statements that I make if I'm trying to write code or if I'm trying to use a method. In this case, it's suggesting different things I can do with our transform.translate. So this here you can see inside of translate, there's a vector3 translation. So this is a parameter. This is a piece of information that I tell the computer to use to be able to do the thing that I want it to do. Now, I don't necessarily know what a vector3 is right now. So let's see if there's other options. You can see there's 6 total options. And this one seems to be really useful. So this one actually says that it will move the transform. It'll change that position by the X, by the Y, and by the Z. If you remember, I was trying to move my vehicle on the Z. So what I can do is, I don't want my vehicle to move in the X direction. I don't want it to move left or right, so I'll just type in 0. I don't want my vehicle to move up or down. It's not a plane or a spaceship, so that's also 0. But I do want to move it in the Z direction, so I'm going to make that 1. Now that we've added our parameters to our method and we have that closed parentheses, we actually now need to add a semicolon. And so the semicolon actually tells your script that the method is now complete. So you can think of how we use periods to end our sentences and close our statements. When you're programming in C#, you use a semicolon at the end of your method to tell the script that this is the end of this line. So now what this will do is update is called 50 to 60 times every second. So in a second, our vehicle will move 60 units, 60 meters in a certain direction. So now if I test this in Unity, when I press play, I should see nothing. Okay, that's not what we wanted to happen. Let's see. Get out of play mode. What did I do wrong? So let me just player control. Oh, I forgot to save. So you can see in our project window, I selected our player controller script and it looks exactly like how we left it when we first opened it. There's no information inside of it. But as you can see in our script here, we've added 2 lines in here. We've added a comment and we've added this method that we created. So the problem is we didn't save. Simple as that. So if you just press Control or Command S, now our script is saved. You can see now in Unity, in our inspector for the preview of our script, we can see those lines of code now. So now when I press play, I should see the vehicle move. There it goes, it's speeding all the way off the runway. And it's flying off into space. Maybe it is a spaceship. Cool. So we've written our first line of code to move our vehicle. So what you're gonna do is in your player controller script, underneath your update method, inside of your update method, underneath the comment, you're going to write transform.translate, and then you're going to use an open parentheses, type a 0, 0, 1, close parentheses, and then semicolon. Now it's your turn.
Okay, we got that. So, funnily enough, it was similar to what I was talking about just now, where when you had pixels in a 2D space and you updated them, you know, 1 pixel every frame, say, it was in 1 second it would move 60 pixels. Now that guy, as you saw, it flew. So those units are quite substantial. It makes me wonder about the size of the game space and how large virtually it's going to be. We've saved ours already with this, so we're just going to open it up, pop it down here, transform, translate, and then he had a few different options. Why is it not doing the same? Oh. Translate. Transform. I think I better look at what it should be. Transform.translate. It was right the first time. Great. I mean, how did he do that then? Translate. Like that. Bet you I've got some settings somewhere that allows me. Let's just try all these. Show only methods. That might be what we want. It's not what we want. Love it. Right, so I wonder if it's just because I'm not using the I don't have an autocomplete function coming up. We're in the right place. We're doing the right thing. I guess we could just write it in, but semicolon. I'll figure that out one time where it'll auto complete. So we've saved ours. Let's just close this out. Pop back into the Unity. Let it do its thing. So is it going to fly off? Sure is. Mine's a lot slower because I imagine the frames per second are a lot slower. Can I check that? No. Curious. Okay. Now, I think that my frames per second is reducing that down. Let's just go back to default settings. So we've only got one 3D space at the moment. I kind of like the old way, but there we go. So let's play it again, see if it speeds up. Look at that, it's flying. Frames per second has gone back up, so we're back up to 60 frames per second now. So it was rendering, if you can imagine, 1, 2, 3, 4 times. So my computer was taking a bit of a hit then. Let's have a look at the CPU. How are we here? So 24%. GPU spiking there. And let's just pop it back into 4 split. And then back down here. And then what we should find is that. Let me just drag this over again. Drag this over again. And then if I press play on there, should see some sort of spikes, I guess, in the GPU perhaps. No, it might just not enough threads. I mean, using quite a lot of them. 16 threads going on, but sorry, not 16 threads, but yes. Okay, so what are we going to do next? Let's have a look. Use a vector 3 to move forward. So we're going to do a different type. Okay. Vector 3.
Our vehicle now moves virtually at the speed of light, just flies straight down our screen. So that's good. We've got the movement in. Now I just want to highlight some things with coding to make our lives a little bit easier. So with our player controller script open in our IDE, my IDE does some really useful things to make my life a lot easier. So one of the big things first is if I start typing a word, say transform, it automatically tries to suggest the word that I'm trying to type, in this case transform, and I can press enter, and it'll complete that word for me. Now, if I type dot or period or full stop, you'll see that my IDE suggests all of these different words. And a lot of these words, especially if they have this little purple icon next to it, these are all actually other methods that I can use, just like our translate method. Now you might hear people say methods or functions in Unity and in C#. They're essentially the same thing, but a lot of people just tend to call things methods when you're using these kinds of statements here that have parentheses. Now, you can think of all of these different words very similar to how you would think of a dictionary. So a dictionary helps you understand a word that you're looking for. In this case, in programming, this is called documentation. And so our documentation, or our dictionary, tells us all of the different words, all of the different actions that we can perform with our transform component here. So I'll use translate again. And now, if we push that dictionary analogy even further, so we have the word translate. And if I use an open parentheses, you'll see that now my IDE suggests different parameters, different pieces of information that I can tell it to use to do something. You can think of this very similar to a thesaurus and synonyms, where many different words have a similar meaning. In this case, we have many different kinds of methods, and these methods all have different ways that you can essentially do the same thing. So in this case, it's asking for a vector 3 translation. Now, in order to get a vector 3, I can actually just type vector 3. And here, now, you can actually see we actually have a suggestion as to what a vector 3 is, which is super helpful. So my IDE tells me that a vector 3 is a representation of 3D vectors and points. What does that mean? Well, in fact, that 0, 0, 1 is just 3 dimensions of points, 3 different points that we use, a 0, and a 1. In fact, that 0, and that 1 all correlate to the position on our transform component. So we have the 0 on the x, the 0 on the y, and then our 1 is actually the z updating over time. We even have these vectors, these 3D points, in our obstacle with our position. You can see the 0, 0, and the 25. That's a vector 3. That's 3 different points that we're storing. So with that information, it's very helpful because we can actually just shorthand this bit of code that we wrote with 0, 0, 1. In fact, if we use dot and then forward, you can see that forward is actually just shorthand for writing 0, 0, 1. So that actually, can save us a lot of time, and especially is very helpful to making our code easier to understand. Because if I told a person to move something 0, 0, 1, they'd be like, I don't know what you're talking about. But if I tell them to move forward, they know the direction of forward. So this is how different keywords in programming can help make our lives easier, to make it easier to understand what is in front of us, but then also translate that into something that the computer can understand, in this case the 0, 0, 1. So if we remove now our previous line of code, now we'll just make sure that we save Always make sure you save before you go back into Unity. And now, in our player controller, you can see that our translate method has changed from 001 to this vector 3 forward. And when I press play, our vehicle is still flying all the way off the screen. So, looks like our code did exactly what we wanted to do before, which is great. And it's easier to read. So what you're going to do in your player controller script, you're going to change your line of code from 001 to vector 3 dot forward. Now it's your turn.
Okay. So, kind of makes sense what he's talking about there. So, if we go back into the scripts, we're just going to swap it out for something that's more legible for a human being to understand. It was a vector 3, wasn't it? So if we do vector now mine, it's not picking up all the bits I need. Maybe it's the first time that it's gone in. What's happening inside here is similar to what's happening here. We're calling on different elements which have already been predetermined in the past. So let's just save that. Double check that it's right. Vector 3 dot forward, correct. Good. Okay, let's just make sure it works. We're moving about 30 frames per second, I think. I wonder if we can find out what the frames per second are. So let's just do a quick. FPS counter for Unity. There isn't one that we can just sort of select, so we're just going to keep going for it. Oh, let me just quickly check if anyone. I forgot to have the chat open. Uh-oh. How do I get... Actually, good point. How do I get this back up over in the old... over here, then chat. And I can see nobody... I said hello. I don't think anyone's going to be watching, to be honest. Oh, there's one. One person watching. That's it. Okay, cool. Let's move on to the next one. Hello, person, whoever you are in the world. Customize the vehicle speed is next. This is all looking very familiar. So, using sort of mathematics to determine what we're going to be doing. A delta is just sort of a vector line from one point in time, I think it is. So it's sort of a continuous... I can't quite remember now. I wonder if you'll explain.
We've fixed our vehicle, so now it flies down the screen once again, extremely fast. At least our code is a bit more readable, but now we need to slow that vehicle down so it doesn't just fly off into the distance. So in our player controller script, we're actually going to use a little bit of math in this method to be able to slow our vehicle down. So first what we're going to do is we're going to want to change the way that we move our vehicle. So currently the way this works is our update method is called every single frame, but depending on how powerful your computer is, you might get 20 frames in 1 second, you might get 60 frames in 1 second, and so really your player could move at varying speeds depending on what kind of device they're using. So we actually want to change that from updating every frame to updating over time every second. So the way that we do that first is by multiplying, and for a computer you should use the star symbol. So if you press shift on your 8 key, it'll create that star symbol, because actually if you press X and use the X key, it considers that an actual letter that it needs to know to use for a word. So we use the star symbol to tell us that we're multiplying something. And then what we'll actually do is we have a class already made to keep track of time, so we don't have to write a class ourselves. So that is called time with a capital T, and you can even see it highlights it in green. That way we know that this was a pre-made class. So now we're using time to keep track of our time, and we actually use delta time to get the change in time between all of our different frames. So now, using this bit of code, we can actually know when 1 second has actually elapsed versus 20 frames happening, 60 frames happening, who knows, we can't control that. We can control how much time is actually passing. So if we go test this, we press play, and our vehicle is still flying down the road, and that's not what I wanted to happen. I forgot to save again. Okay, so back in the player controller, just make sure you save, Control or Command S. That way it always updates the script in Unity. So now, when I press play, we should see our vehicle moving, albeit very slowly, but because of that little bit of code we added, we're actually now moving 1 meter a second. You can see, if you want to time it, it would probably be just about 1 unit every single second. So, cool. Now we have our vehicle moving by time. Granted, it's moving very slow, but we can fix that pretty easily. So what we're going to do in our player controller, we're just going to multiply by a random number using that star symbol. So we'll multiply by, say, 20. So it should move about 20 meters every second now. So now if I test and I press play, and I forgot to save again. Always remember to save. Now when we press play, there you go. Now it's moving nowhere near as fast as before, but definitely not as slow either, which is great. As a fun little tidbit, the way that this formula actually works, this little equation that we have, so in fact, vector3.forward is storing a 0, a 0, and a 1. And so when you're actually multiplying it by the time and by 20, you're actually multiplying each of the different values. So first you multiply your 0 by time and by 20, which will always be 0. Then you multiply your y, which is 0, by time and 20, which is still 0. And then you multiply the z by time and by 20, which gets you 20 meters a second. So just a fun way to kind of see how the math works, and would definitely save a lot more time than just typing 0 times time.delta time times 20, comma 0 times time.delta time times 20 times 1 times time.delta time times 20. So a really helpful way that, especially this shorthand, makes our lives even easier than before. So what you're going to do is, in your update method, you're going to change your transform.translate to just include a star symbol for multiply, and you're going to multiply your vector3.forward by time.delta time, and then you're going to multiply all of that by 20. So now it should move just about 20 meters a second, so that when you test your game, you press play. If you select the vehicle while it's moving, you can see the Z value changing, and if you used a stopwatch, I'm sure you can see that it probably moves just about 20 times every second. So now it's your turn.
Cool. Okay, that makes a lot of sense. It's really good, really informative. It's kind of reminded me a lot of the stuff I used to work with. I'll be honest, I think it's best if we just get two of these, one of these. Let's go back to a 2x3. Move our. Do we need the hierarchy? Yeah, we do. Move the project down there. Just so we got a bit of a smoother experience. Cool. So we got then. So we're going to times time dot delta time times 20. So we're using the start time dot delta time times 20. I feel like that isn't quite perfect. Capital T, lowercase d, and save. You know, mine doesn't seem to be calling from our update to tell me what these things are. So if you know, I guess leave a comment. It's something really straightforward, I'm sure, just to set up. Right, we've done that. Add a rigid body, so that's going to be the physics of the object. Right now the vehicle goes right through the box, correct. And we want it to be more realistic, so I forgot to press play. Play. All compile errors means I've missed something somewhere. So save, close, wait for it to compile. I'm sure, have I got, of course I have. Capital T, I missed the capital T out, look at that. Didn't like it, so we go back in, capital T for time, save, and close. Go. And it's smoother as well, good. And it's moving at 20 frames per second. 1 crocodile, 2 crocodile, 3 Mississippi, 4 crocodile. Sweet. Cool. Happy days. Let's move on.
Our vehicle now speeds along at a normal rate instead of incredibly fast or incredibly slow. And now we want it so that we, instead of just driving straight through this box, actually can collide with it. In order to simulate physics in our world, we actually need to add something to both our obstacle and our vehicle. And we'll do that using our components. So our component system can add a lot of different properties that people regularly use. In this case, a property that people will commonly use for physics is a rigid body, which is a physics concept, and in this case allows us to interact with this truck here that we have as if it had real simulated physics on it. So now it's a solid object. You can see that on the rigid body component in our inspector. It has a mass, so we can actually make this heavier. We can use gravity or we cannot use gravity. So there's all of these different options. In fact, I think our inspector is getting a little bit too crowded, so you can actually click on the little arrows next to all of the component names, and it will compress down each of the different options. So that's certainly very handy if you have a lot of different components. So now we can see our rigid body component, which is great. And then on our obstacle, we can also go and with our obstacle selected in the inspector, we click add component. If we type in rigid body again, we can add another rigid body. So now our obstacle and our vehicle both have rigid bodies, which means they're both using physics, they both have mass, they both use gravity. So that's really helpful. And then one other important component to note in our list of components in our obstacle and our vehicle is actually these mesh colliders that we have on both of our objects. And our colliders are basically our ways of telling our simulated world that these objects can be collided with. So it knows that because there's a collider on this, when it runs into something like the ground or when it runs into something like our vehicle, it should do something like make it stop because we have a rigid body on it. So if we actually press play, you can see our vehicle collides with our crate, it goes flying off. If we were to turn any one of these things off, so for example on our obstacle, if we turn off our mesh collider, our box actually just flies straight through the ground, and that's because our mesh collider is telling our game world that the box no longer collides with our road, so therefore it can just fly straight through because it's not supposed to collide. So really fun things that you can do, and just to kind of make our little driving game simulation a bit more realistic, we're gonna increase the masses of these two objects just to make it a bit more fun, make it interesting. So we'll make our obstacle, our little crate, maybe about 20 kilograms or so. And then the mass of our vehicles, I don't know, maybe something like 1,000. So now this has even more weight behind it. So when it hits that box, you see a slightly different effect happen. Yep, see? So it took much longer for that crate to fly over the vehicle because it was much heavier. So, fun little things you can do to create better simulated worlds in your games using things like colliders to tell your objects to know when they've collided with something like our vehicle and our box, or even our box and our road, using rigid bodies to be able to create physics on our objects so that way our obstacle actually has weight, our vehicle has weight, and we're using gravity, so it's actually being pushed down into the ground at all times. So what you're going to do is on your vehicle, you're going to select it in your hierarchy, and you're going to go into the inspector on the right side, click add component, and you're going to add a rigid body. And then the same thing you'll do with your obstacle, select it in the hierarchy, go to the inspector, click add component, and then make sure you either search for or select the rigid body component out of the list. So you can do that either by going to add component, going to physics, and then you can see all of the different options like the rigid body, or you can just type in rigid body, and there it is. Super easy. Now it's your turn.
Cool. That was quite effective, wasn't it? Only a couple of buttons, and we can make things physical. So let's do that over here. I always need to forget to do that. So let's just select all of ours. Add object. If it breaks it, I'm just going to undo it. So there we go. Let's just see what happens now. Oh, hang on. Of course, that's not going to work. And stop. Select that. Add component. Physics. Rigid body. So that's those two sorted. Let's play. And he's gone. Okay, cool. That went flying. Now, let's just select this one. So we had a 20 on there, so let's just do the same. I'm just going to copy and paste. I'm not going to multi-edit. Oh, I'm going to stop doing that. Sometimes I want the scroll to go a bit quicker. Okay, and another one, and another one, and the last one. And our tank. Tanks, they're normally in the tens of tons, so let's just stick with what he had. Just get a ton. Okay. And see, that was too fast, too fast, too fast. Press play and see what happens. Good luck. Wow. Did nothing like I thought it was going to do. So let's have a look. 20, 20, 20, 20, and another 20. And let's just tidy this up a little bit. Make sure there's nothing that's over or under 0 on the Y. That's cool. Let's press play again. Hits the first one, hits the second one, goes bouncing, hits the third one out of the way. Great. Okay, cool. And that's it. What is this thing here? Boulder. Is that going through the ground? It is. It's because it's a sphere. Let's just pop that up by 1. And in fact, let's pop all of these things. Maybe that's because they're on the 0. Done it again. That's going to be fine at 0. That's going to be fine at 1. It's because it can't quite work out what to do when it's underneath. That's fine. Let's reduce this one down. Try and get our guy to go all the way to the end. Play. Hits the first one, second one, third one, fourth one. There we go, we fixed the boulder and he goes flying off the last one. What is going on there? There's nothing different. So, I mean, it's going to be the shape of it, isn't it? Let's just rotate it a little bit, so sort of 45 degrees. Oh, he's flying all the way over there. Love it. I know. Tanks are 10 tons, so let's make it 10 tons, say. Right, they're actually more than that, but I'm going to make ours 10 tons. Just smashing through everything now, look at that. Smash. Happy days. Even behaves more like a tank. Should we just give it a bit more? 20? It's so heavy, it can barely figure out what it wants to do with these things. It's brilliant. I like it. 10's good. Let's just stick with 10. Let's just save this for a minute. Okay, we've done that. We don't actually need to do the last two. We've already done it. Okay. And then a lesson recap. We've done quite a lot. I don't know if I need to do a recap really, but I guess I will. So we created our first script. Then we added the comments, which is the forward slashes, just so that it's a bit more easier for us to read and the computer won't read that bit. Then we gave it a forward motion, initially using an update of frames, and we saw that how that can be affected by the frames per second as well. Streaming and letting it go is obviously caused a problem. But then we changed it to a vector 3, and then we changed it into a delta time. Now this is when it got a bit spicy, because we were timing it by using the time rather than the frames to determine the speed itself. So it would move 20 units every 1 second, essentially. That fixed our little problem with it either flying off or not flying anyway really fast. Added some physics objects into it all, and now we're going to mark it all as complete. So next, yeah, that's fine. Next we're going to be looking at 1.3, hoping will be tomorrow. So we'll be catching up then. As I said, so earlier, we're going to be watching an episode of The Vale. I'm happy with that. So that was quite good. It's bringing in a lot of the old memories of when I made something in the past. So I'm going to sort of pause the music. I really like the music. It's really good. So we're going to just pause that. Head on over to our episode 3 of The Vale season 1, and it's this episode because we're on episode 3 of the stream as well. Oh yeah, very important, there's swearing in this, so any children, anyone under, I don't know, does it matter, 15, go to bed, or go do something else, go outside. It's beautiful outside every day, even in the winter. I enjoy any weathers. Spend a lot of time outdoors. In fact, more time outdoors than I do on computers these days, but there we go. So, I can't remember how to do it, so I'm going to interact there.
Hi, I'm Phil White, author of The Red Plague, the UK's Grey Squirrel Hunting Manifesto, and I'm killing animals. Today, I'm joined by somebody who's been in the business for over 30 years. Like me, our guest believes the invasion of the grey squirrel is something us guardians of the Great British Red is a problem that has to be stamped out. I picked him up outside the train station, and that's what brought him here today. So, tell us a bit about yourself. My name is Bob Hughes. So today you've brought the Ammo Big Cat 1200. Anything you'd like to say about this gun? Well, nothing really. Aside from it's very good at killing grey squirrels.
Here he fucking is. Hey. Come and sit down with us then. Watch this, get ready for Saturday.
What is this?
It's one of my hunting DVDs, it is.
Get off my land, you
Can I just go to the anime convention on Saturday? No! You're fucking coming, Ton. It's gonna make a fucking man of you, this is now. It'll put some fucking ears on your balls.
But Beaton, I don't really agree with hunting. I like animals.
Oh, fucking arca this. I like animals. Fucking watch your fucking tampon don't fall out now, Ton. Now go on, if you're not gonna watch this, fuck off upstairs. I've had enough of you now. Oh, and me and your mother are going out for our 1 year anniversary tonight. We left you £2 for a takeaway.
£2? That's not enough.
Oi, ungrateful. You fucking have what you're fucking given. Anyway, think £2 fucking plenty for you. Fatso.
Oh, it's fucking nice in here, innit?
Yeah,
Swanky like, innit?
yeah,
How's your wine?
fine,
How was work today, Anne?
fine, thanks.
Anything, I don't know, funny happened today, Anne?
Not really.
Oh, fair enough, alright.
Actually,
Yeah?
actually it wasn't that funny.
Oh. Can't believe we've already been married a year now. Ah, the wedding though. Best day of my life, that was. It was like, I can remember as if it was 5 minutes ago. Oh, I'd give anything to go back. Come on now, big boy, you got this. So you walk down the aisle, look her in the eye. It's the woman your dreams are about. It's your future. It's all you've ever wanted. But you'll be fine now, boy. Come on, you soft cunt. You'll be fucking fine now, bud.
You ready?
Yeah, aye, man. Fucking right as rain I am, but.
Bit of nerves, is it, bud? Fucking shitting in your knickers, are we?
Nah, don't be soft, man. Fucking right as rain. I'm fucking right as rain, boy. I'm fine.
You can still have a can with us, man.
No. I don't want to calm, but Look, I'm fine. I need to keep a straight head on. I need to stay sober for this one now.
Come on, bud, have a fucking slurp, you soft cunt.
Fuck aye. Be trust us, it'll sort you out. I had a few tinnies before all 5 of my weddings. And all the way through the wedding afterwards, I was just like, yeah, fuck aye.
It's a long day. I'll have one after. I don't need one before the wedding.
Yeah, just have it.
Oh, well, alright, go on then. It's just the one. I'll wet the whistle.
Will you take this man as your lawful husband, to have and to hold, from this day forward, in sickness and in health, till death do you part?
I will.
And will you take this woman as your lawful wife, to have and to hold, from this day forward...
I fucking believe it. I fucking take her about it.
And now we commence with the reading of the vows.
Beaten, I promise to love you, honour you, and cherish you as my husband. I vow to hold your hand in my hand, to hold your head in my hands, and to hold your heart in mine. I love you, and you are my husband for all time. I pledge to be your ever faithful, honest, and loving wife.
Sandra, fucking woman, I fucking always loved you, and
So yeah, as I've said, didn't want to do a speech, but I'm doing it. Because, you know, Beat, good lad, isn't he? Good fucking lad.
Right, yeah. Yeah, thanks for coming, everyone. Yeah, it's been a lovely day, hasn't it? Yeah, thanks for coming anyway. Yeah, Sandra, right, isn't she? Oh, you know what? I can't really do this, but tell you what I'm gonna do. I'm gonna let Chaz Kroger, fucking best band, fucking singer ever fucking going, speak through me for this one. Sandra, look at me in the eye.
Never made it as a wise man. I couldn't cut it as a poor man stealing. Tired of living like a blind man. I'm sick of sight without a sense of feeling. And this is how you remind me. This is how you remind me of what I really am.
Ah, what a day that was.
Well, no, you drank so much you were in a 3-day alcohol-induced coma. We missed our honeymoon.
Every day is my honeymoon of you, Sand. Now, come on, where's this fucking food then? Roll over here, love. Come on. Let's put them fucking bottles down. I'm just gonna fucking maneuver. Here we are. Oh, yeah. Yeah. Oh, hey. I wanna be a rock star. Good night.
Brill. Love it every single time. Okay, so thank you very much everyone for watching. It's been episode 3. It's been good. Learned a lot already. A lot's coming back. So have a good evening. Enjoy yourselves, and I will see you on the next stream. Thank you very much.